In this one, you're told that visible light passes through a diffraction grating like this one here with 900 slits per centimeter, and there's a screen behind the grating 2.66 meters away. And they say visible light, they just mean white light with all the wavelengths of light in it. So you could think of the light coming in as having wavelengths all the way from 400 to 700 nanometers. And it says the maximum between two wavelengths is separated by 3.22 millimeters on the screen. What is the difference in wavelengths between them? So recall that the pattern kind of looks like this, big central maximum, and then there's other maxima like this. So they're just saying that one peak, one wavelength there, and another wavelength there, that separation, delta y, is 3.22 millimeters, right in there. What's the difference in the wavelengths that made those? So what you'd want to start with is remembering really that we only have one equation for gratings, and that is the equation that tells you where these maxima occur. It looks like this: d sine and the angle of the maximum equals the order of the maximum times the wavelength. So d is the separation between the little slits that are letting light through here. So you were told this has 900 slits per centimeter. So to get d, you have to turn that upside down. Right? So for d, it's 1 over 900, and then you turn the unit upside down, centimeters per slit. Because that's what d is, the width of each slit. How many centimeters wide is each slit? And it's 0.001111 centimeters. Because slit in the unit doesn't really mean anything. That's just the width. It's 0.001111 centimeters. So we have d, and next we could think about, actually, for small angles, this will be a little easier. And we know the angles are going to be small because we know this is 2.66 meters away. We're talking about heights of only a few millimeters. So for small angles, we know that sine theta, let's see, is what? So we know that d sine theta, if we thought about this distance up to that maximum like that, sine of that angle is the height, y, over the separation, L. So we could say d times y max over L. So instead of the angle where you get the maximum, it's the height, y, where you get the maximum. And this is the y-axis, and this is 0. So let's see, that equals m times the lambda where you get the maximum. So this is the equation we're going to use. And let's think now. So what did they tell us? They told us the separation between the maxima for two different wavelengths. So we want to solve this for ym. Let's see, so that y, we're going to do it for lambda 1, is clearly L over D, and then m, there's one number they said that I didn't write up here, is first order. Light passes through diffraction grating, blah, blah, the first order maximum. All right, so the first order part means it's the two rays that are getting up here that are out of phase by one wave. So basically m equals 1. Right, so m equals 1, so we can leave it out of the equation because it's 1. So it's L over D lambda 1. And then the second one is at a height y lambda 2 equals L over D lambda 2. What we care about is the difference. So y lambda 2 minus y lambda 1 we know is equal to 3.22 millimeters. So you can see we just got to say 3.22 millimeters equals this expression minus that expression, L over D times lambda 2, but notice they both have an L over D in front of them. So we can just say L over D times lambda 2 minus lambda 2. Oh my goodness, this is what we're looking for right here. The difference in the wavelength, lambda 2 minus lambda 1. So in the end, delta lambda is just 3.22 millimeters times D over L. So D being 0.00111 centimeters, 0.00111 centimeters, over L, 2.66 meters. And if you do that and get all the numbers right, you got to keep up with millimeters, centimeters, and meters in one equation, but you get 13.5 nanometers. 13.5 times 10 to the minus 9 meters. The reason, in the end, the math didn't turn out very complicated is because the height is linear with the wavelength. If you assume small angles, you can see y and lambda are both just sitting here to first order. And so that's why a little change in y is proportional to a little change in wavelength. You really just have to multiply by d over L to get it.